Welcome everyone. We'll just wait a few more minutes for everyone to get a chance to show up. All right. Let's give one more minute for people to show up, and then we'll get started. All right. Welcome everyone to our first Q&A workshop, hosted by the Davis Engineering team, and we're excited to present Sanjeev Sharma, and he'll be presenting today.
Yeah, so this is going to be our agenda for today. First of all, welcome everyone to the first DET workshop Q&A. And now, shortly, we're going to go through Sanjeev's presentation about his background, his career. And then the bulk of the meeting will be a Q&A with Sanjeev, obviously. And you can either unmute and ask your question or put them in chat, or we will just use the questions that we got from the form. Then we will have a couple minutes dedicated to answering questions people had about DET, and then we will close around 10.
All right, so before we go into Sanjeev's presentation, make sure to join our Remind. You can do this by texting at Team Davis to 81010. And make sure to include the @ symbol when you're texting the number. And this Remind is basically like a text reminder app. And this will ensure that you won't miss any future events, workshops, or opportunities hosted by the Davis Engineering team. All right, so without further ado, let's welcome Sanjeev Sharma.
Hi, thank you for allowing me to have this opportunity. Welcome, everyone. Good morning. So let me start with my introduction and walk you through my career profile, and then I would love to get into the Q&A more importantly. So my career started off as a mechanical engineer back in India, and I've been in this field for about 25 years now. I started off in the Indian Railroads, first doing some operations, maintenance, and running operations in the Indian Railroads from the mechanical engineering side, and then doing high-speed passenger rail car design for about 5 to 6 years there. And once I had done a lot of that design, I realized that I wanted to study more and get deeper into mechanical engineering. And it's kind of I'm a fan of lifelong learning. Wanted to learn more, so I came to the U.S. to pursue my master's in mechanical engineering from UC Boulder, and there I wanted to do more research in either railroad or automotive. But as the turn of events took place, there was 9/11. There was like very little funding for research in aerospace. I was diverted towards a new industry, which was hard disk drives. So in computers, we have hard disk drives, which are electromechanical components and very highly specialized. So UC Boulder had a special unit dedicated for that research, and I got associated with that as a graduate student pursuing research in that area. My research was liked by the companies that sponsored the research. In the end, when I graduated, I got a job in Seagate Technology, which is one of the leaders in hard drive design. I moved to Minnesota and worked in Seagate Technology for about 9 years. We were, dealing with making very highly specialized electromechanical equipment, a very high end technology company uh, producing hard drives in mass. And you've all seen how the data density on computers storage has gone up in exponential fashion through the decades. When I joined, the hard drives used to be like an individual hard drive would be about 2 to 5 gigabytes, and now it's in terabytes, which is like 1,000 times more. It's a very fast moving industry. I love my job there. However, at the end of it, there was more of a challenge in the technology space from solid state drives. And the hard drive industry was shrinking. There were 20 players initially, and now they're down to three. And there were constant jobs, layoffs and stuff. So, and the industry went through a downturn, which is why I started looking outside that industry. I applied to a whole bunch of industries, but then I got a call back from SpaceX in Los Angeles and interviewed with them. And in fact, Elon personally interviewed me on phone. It was a job he wanted for, he always wanted to hire people from outside the industry because he claimed that the aerospace industry as such was very slow due to negative incentives given by the government for extending projects and extending costs. So he wanted to hire from outside the industry, and he wanted someone to work on reusing and recovering and reusing the first stage booster. And I had no background in aerospace by then, but he was basically looking for fundamentals. And I had done rail card, I had done computer hard drives, very unlike dissimilar subjects. He interviewed me. He found that I was a good candidate. I joined the project, and for 6 years I was at Los Angeles Hawthorne in SpaceX. When I joined the company, we had just flown the F9 Falcon 9, fifth flight of that, and we were not able to recover the first stage booster. We were not even able to figure out what was going wrong with our efforts. And by the 14th flight, we could get the recovery done in one piece. By 21st flight, we could land it at 19th and 21st flight. We could land it with precision. And later on, rest is history, of course. I mean, the project proved out to be very successful. Even I was very skeptical of it at the beginning. So that was a great time at SpaceX. And once I'd done about 6 years of it, and we went from an original design, which was the Block 4 design of the first stage booster, which was reusable only once, to a Block 5 design, which again I was a part of from the mechanical, structural, and dynamics end. Um, and we can now reuse the Block 5 10 times over, which dramatically changes the cost of access to space. And very satisfying project to work on. But after doing that for 6 years, I wanted to look at a bigger challenge. And I also, for family reasons, wanted to move to Northern California. So I started looking at Silicon Valley companies, and now then I applied to this company that I work for today, which is in drone delivery. This is called the company is called Matternet, and what we do today is deliver blood supplies, pharmaceuticals from hospitals to labs in cities. So we're operational in Zurich and in Raleigh and in Florida. And we just made a big announcement that we are going to be operational in Abu Dhabi. So essentially, delivery of medical supplies and essentials from hospitals to labs or from pharmacies to patients in a very rapid, on-demand fashion by drones. That's so I head the technology function in the company, which my title is head of technology. I look at next generation products, but I also have dual charge of drone engineering. So a drone is essentially a flying robot. It comes together by whole bunch of sensors, controllers, and propulsion systems, energy storage. All of those challenges are involved in the drone, and it's a pretty interesting problem to solve. So that, in a nutshell, is what I've done in my 20 plus years of engineering. And I always look back and kind of remark that life is a series of accidents. You can never foresee what you're going to do next. There are industries that don't exist when you graduate from high school or from your undergrad. They'll be your calling in the future. So it's always amazing to me that I started my life, literally working on steam locomotives initially in India, and now I've worked on reusable rockets and flying drones, which is very remarkable. So with that, I think I'll pause here and see if there are any questions.
All right, so like if you have any questions, you can leave them in chat or you can unmute. And if not, we'll just go to the questions that you guys responded on the form.
All right, I'm gonna start with the questions that looks like we have one in chat. So the question is, after school, have you been able to find the work you want?
Yeah, so I think there's two aspects to it. One is I always knew that I wanted to be an engineer, and getting a good engineering job was it's not difficult, it's not easy, but you have to define to yourself what are you passionate about. Even engineering is a huge, big, wide open industry. There are jobs in engineering which require skills in chemicals, in construction, in electronics, in programming. So there's a whole bunch of things to choose from, and so you should decide. You should probably try out a little bit of everything if you really want. Once you've made up your mind that you're interested in STEM, you're interested in engineering, I would encourage everyone to try out different projects and see where they gravitate towards, where they like the work that they are doing, where they get energized by the achievements that they get in that field. There's a difference between being good at something and being passionate about something. You may be good at 10 things, but you may actually enjoy doing one or two things more than the others. And in my case, it was electromechanical systems. And this, there's a huge bunch of choices: communications, radars, everything. It just depends on what your calling is, and I think I've always made choices on which job to choose next based on whether or not I will be fulfilled with that passion. So I would encourage everyone. I mean, I think this question is more oriented towards how do you. My interpretation is that this question is oriented more towards how do you choose the job that you want to work on. Well, look ahead, talk to people in that industry. Uh, I would encourage people to take up internships and realize what areas of the company do what, and then make a wise choice. Never feel trapped in a job. My fortune was that I think all of my choices have paid off. I've never really changed very many jobs. I've only done one, two, three, four jobs in my life, even though it spans about 20 years. The first job, Railways, was 6 years, Seagate 9 years, SpaceX 6 years, and now Matternet about 3 plus years. So didn't have to job hop very much.
Awesome. So we have. I'll go through a couple questions that we have on our list. So this is a pretty vague question, but you can answer in any way that you like. What is like what's a significant challenge that you've experienced throughout your career, and how did you react to it, and what did you learn from that challenge by going through it?
Yeah, so there's been many. I mean, just the challenge of changing industries. It's very scary. Let me tell you. In engineering, unlike in medical or other professions or legal, in engineering, it's a practice based profession. What I mean by that is you learn fundamentals at school, at your high school, at an undergrad, at your grad, but you actually learn the industry by what's called domain specific knowledge, and that only comes by working in it. And there are very few engineers. When I look around and I see my colleagues, there are very few engineers who actually switch industries, which I've done, I think, 3 4 times now. And the problems with that are enormous. I mean, when I worked in railroads, I was working on very large structures, very large, tons of like carrying capacity of carriages and stuff like that. And when I switched to computer hard drives, that was a totally different world with microelectronics, with micro motion control and thermal control, and the problems and the aspect size was totally different. And with that, the language, the challenges, the background, the history you need to have is also totally different. So every time I made a transition, it was like standing at the bottom of a 90-degree overhanging cliff, or more than 90-degree overhanging cliff, and trying to climb that. And a lot of people don't do that, and as a result, I've seen a lot of my colleagues remark that, hey, I'm just stuck in this industry, stuck in this job, and I cannot even think of going out because it's a big challenge. Well, the thing is that focus on the fundamentals. I mean, that's been my way of coping with these big transitions from railroad to computer hard drives, and then again from that to aerospace, and that from that to drones. Is focus on fundamentals, keep learning the fundamentals, keep brushing them up, and then it's good in once in a while to have that empty feeling in your stomach, to look around and say, hey, I don't know what I'm doing. And there's a level of anxiety. When psychologists do researches, they find that there's a level of anxiety that's optimal for prime performance. If you're if you have a very low anxiety, that's not the ideal state for learning and doing. And if you have a very high level of anxiety, obviously you're making poor decisions. So keep that strife in your life, I guess, is my motto. Is once you get too comfortable doing something, look for something new. And the way you cope with it is rely on your fundamentals, rely on your capabilities, be always learning, always keep looking around, and yeah, I'm on a continuous learning spree. I'm always looking at courses, online courses, to augment what's going on right now, learning new tools, learning new programming, new ways of doing things, and stuff like that. So always be curious and keep learning. So that's kind of the thing that keeps me going through these challenges.
All right. Megan Richmond had a question in chat. She asked, "What languages do you guys program in?" So, like, I'm assuming at like SpaceX and also currently at Matternet. And
Yeah, yeah, sure. So usually, I think Python has now become the de facto standard for a higher level language. And as engineers, it's not a language; it's a programming interface. But I'm very used to something called, I don't know if you guys have used it, MATLAB. Uh, what I've seen is mostly in companies like Seagate and SpaceX, as well as now in Matternet, is that engineers who are not as proficient with programming, because not all every engineer is a software geek, start using MATLAB for their own processing, for their own programming needs, and then once the developmental code and the development program is up to the point where it can be implemented in production in over a wide application area, then someone works with them to port it into Python or C++. So I think these are the two main, Python for a high level language and C++ for implementation at a board level. So these two are kind of the main workhorses I see in terms of programming language and tool set across the companies that I've worked in and I'm aware of. And again, this is mostly for what I call software for hardware, which I'm a hardware person. When you deal with software in a pure sense of cloud computing, AI, machine learning, there are several different programming interfaces and languages, and I'm obviously not an expert on that. I'm mostly on the interface of hardware and software, which is why I say Python and C++. But the answer would be different if you talk to an actual software engineer.
All right, another question that someone had was, what aspects of engineering do you like? Like, what aspects of engineering do you like most?
Yeah, so I think engineering, the best thing, so there are a lot of things that attract me towards engineering. One is the applied aspect. You're solving problems that make an immediate difference to the society. And this is just a personal preference. It obviously depends on various people having various inclinations. But I'm very impatient by nature. I want to work on something that gets applied. In Indian railroads, I could work on passenger rail cars that could come into existence within 2 years. I mean, I could even design parts in the morning and go to the factory floor in the evening and get them made. So it's very satisfying to see your work come to fruition, as opposed to if you're a policymaker, or if you're in legal reforms, or if you're in uh, in fundamental science. Nothing against those professions, but it just takes a very long time to get your work into the hands of the society. As an engineer, there's almost instant gratification of what you're doing gets implemented. And the second thing about engineering is the creative aspect of the problem solving. Whether you're designing something, or you're making a better way of maintaining something, or flying. Let's say you're an aerospace engineer who's responsible for upkeep of Boeing 747s, or Boeing 787s. There's a lot of creative decision making, problem solving that goes into optimizing performance. And that's one aspect I like in engineering, is that it's not doing the same thing over and over again, but challenging the process, going back to basics, and saying, how can this be made better? And engineers do that every day. So, I mean, all of these aspects make engineering very fulfilling for me. And obviously, one of the big things that I focus my life on is working on things I call infrastructural technologies, which means that you produce the technology, you make it cheaper, you make it more accessible, be it railroads or rockets or hard drives or drones, and then let the society decide what the best function of it is. So it's not just focused on weapons. It's not just focused on one particular segment of the society. It's open to the entire world. The entire world benefits when you deliver in your chosen area.
Right. So you mentioned a lot about knowing your fundamentals, and then you use that to expand upon, and that's how you're able to essentially work in many industries. What do you what do you define as fundamental specifically? Like, are you referring it to as more like technical knowledge, or is it more of sort of principles of design or
Yeah, I think it's all of that, I guess. I mean, what I mean by fundamentals is starts from science and math. I've had a lot. So I one of the things I forgot to mention, I guess, is that throughout my engineering career, I've been very passionate about mentoring the next generation of engineers. I've in Minnesota when I was in Seagate, I participated in Project Lead the Way as a mentor and a judge in a lot of these science fairs and their projects. In SpaceX, I was a mentor for Hyperloop, and in Matternet as well. I'm a mentor for some FIRST Robotics and some project engineering project teams remotely these days. So essentially, what I hear from sometimes I hear from young engineers is, why do we need to study math? Why do we need to study science? And we already know that, if you want to work as a software engineer, we don't need to learn physics, things like that. My advice to everyone is, uh, firstly, I mean, you don't know where you're going to work on next. Human growth is so rapid that the technology is going to change so rapidly. You don't know where technology is going to be in 20 years and what skills are required. What we do know is fundamentally science and math, that platform will always be required for any STEM or any engineering function. So learn it as best as you can. And by learning it, I don't mean that ace the exams and just do what your teachers are telling you to cram up. By learning it, I mean just grab the fundamentals and know where you can go back to, and you have to when you're faced with that challenge. So learn your trigonometry, learn your calculus, learn your physics, mechanics, and electricity and sound and light. If not for a specific application, specific purpose, if not for that, then just for the joy of learning. Because if you really want to develop a career in STEM, you better have a passion for science and math. If you don't, then you're probably positioning yourself pretty incorrectly. So first fundamentals comes from science, and then comes application, and then comes projects, and economics. So all of these things are kind of just layered on top of each other. So these are the things I call fundamentals. And these days, it's incredible how much you can learn just by yourself. You don't even need to go to the best university. You just invest in yourself. You just self-study and keep learning and applying these things. And that's what I mean by fundamentals. Essentially, start from science, go to applications. So science is essentially theory and the theoretical basis, and then engineering is a layer of application on top of that. And then even beyond engineering, there is product market fit, and there's economics, and there's management. So these are the things that actually come on top of engineering and make and kind of give you a feel for what projects are going to be successful. How are you going to navigate and work in big teams? How are you going to collaborate? Because nothing is achieved on an individual basis. Everything that I've achieved in my life is essentially due to having good colleagues and good mentors and good bosses and good teams, essentially. So these are the things that you have to fall back on. These are the things that will make you successful in a long-term career in STEM.
All right. Another question we had in chat was, is there anything you wished to learn before you started working in your field?
Of course, yeah. I mean, uh, it's yeah. I think so. Well, I see myself as a T-type kind of a personality. What we mean by that is that you have a narrow and deep knowledge of one field. In my case, it's structurals, vibrations, dynamics, and then a broad overview of a lot of fields. This could be controls. It could be electromechanical actuators, mechanisms, systems, sensors, and then yeah, I mean a lot of other things like power electronics, and so all of these other branches. So you have to basically, and it's more by choice than anything that I've kind of fashioned my learning in that way. I believe that you shouldn't be a total generalist, meaning that you just know little bits of everything but not anything deep enough. So I think you should choose your passion and keep growing as an expert in that one area. At the same time, not ignore that there are other things to be learned, and keep learning them. So I always say to my, to the people I mentor, it's really great to know one thing really good, but then all the other relevant accompanying things, you should know them to the level of a person who can actually have like a meaningful view of what's going on with the work that you do in the interfaces. So if I'm a mechanical engineer, I should know a little bit about aerodynamics. I should know a little bit about power electronics. I should know a little bit about software. I should know a little bit about high-speed signals, communication theory, stuff like that. So I don't stop at where my uh, sphere of influence or sphere of responsibility ends. You should just try to broaden it a little bit more. And in terms of if I wish I had more, I always wish that. I always wish I had studied more content of these related fields, and I always keep investing time during weekends, vacations, whatever, reading more about them. So yeah, I mean there are things that I would love to know more about.
Awesome. So there's a question in chat, and this is how it goes. Applying to Matternet, what is the biggest problem that you're working on right now?
Yeah, so drone delivery is very challenging. The biggest problem that we are working on right now is so we have a quadcopter. The Matternet uses a quadcopter that's about 13.2 kgs in total takeoff weight. It has a payload of 2 kgs that can go all the way autonomously. Once you program it to reach a certain GPS coordinate, it can just fly by itself to about 20 kilometers away. And we are operating this in flights today as we speak in Zurich, over the city of Zurich, or the heart of Zurich. So there's like kindergartens, there infrastructure, there's people moving up and about, and we're flying 400 feet with a 13.2 kg drone, which has lithium-ion batteries, which are, if they are punctured, they can result in a huge fire. So what we're doing is inherently very, very risky. The problem that we keep trying to be paranoid about and keep trying to solve is how to increase safety of this operation. Anything that humans do in technology and engineering can become very, very risky. And so when we moved from horses to cars, obviously there was a lot of outcry about how the cars are causing accidents. And then when we moved from cars to planes, there were a lot of accidents in the aerospace industry initially in the initial learning years, and sooner or later, I think when like millions and millions of engineers like me work in these industries and keep refining them, we trying to make them safer and more reliable. Now at this point, we have cars that don't break down for 150,000 miles. We have airplanes where there's a less than 1 in a billion uh, probability of anyone getting fatally injured, which is incredible because airplanes are always fighting gravity, and yet the airplanes per miles are safer than cars even. So as an engineer, I think in the drone industry, our primary objective is to improve the safety of our operation through technology. I mean, a lot of other people are focused on how to train people, how to have our operators trained up enough to have the safest operation. And my focus is on technology, on how to build the safety into technology. Because when you talk about autonomous systems, whether it's autonomous cars or autonomous robots or autonomous drones, safety has to be built into your programs, into your sensors, into your algorithms, and only then the operators are actually just pushing buttons for setting up the drone or the autonomous car, and beyond that they don't have much control over safety. It's mostly built into the technology, and that's the main challenge that that I'm working on, is how to make our drones safer through better sensors, through better software technologies, and computer vision, and bringing in everything that we can to make the drone fly safer.
Cool. So, aside from the overarching goal of creating or increasing safety within Matternet and the drones and how you operate those drones, what do you do more specifically on a day-to-day basis? In
Yeah,
order,
so I'm my position in Matternet is an engineering manager. So, and it's a startup. It's a very small startup. It's I think our total size is about 90 people, out of which the technology or an engineering team overall combined, software, hardware, and other parts of it are just about, I would say 35 or so. So I manage a team of about 10 to 15 engineers at a time. So my day is essentially a lot of meetings, first of all, and so the things are different when you're in the individual contributor versus when you're a manager. As a manager, your biggest priority is to line up the team around a goal, and define the milestones, and enable everyone to achieve them, and then keep track of the progress, and report back to executives on how things are going. So keeping track of basically project management in a word, in a nutshell. And so that's one of the biggest things. So my day would look like, there would be 30 to 40% time spent in meetings, which sounds really dull, and it is at times. I try to avoid sitting in huge meetings, and just being passive. One of the things I learned at SpaceX was SpaceX has a very, very open policy on this. If you're in a meeting where you're not contributing, you're fully encouraged to walk out. You could be in a meeting with Elon, and he wouldn't mind if you just walked out, and he would actually question you if you did not speak for an hour. He would basically say, "Are you getting anything out of this meeting? If you're not, you're probably better off working on your project." So meetings is number one, and secondly, then focusing at being in a small scrappy startup, I'm also doubling up as an individual contributor. So I like the time that I love the most is when I get to spend time doing my own designs and analysis, and producing a direction for the team to work on. That's about, I would say, 30 to 40% again, and the remaining 20% is mostly uh, traveling, or what I call accessory overhead, essentially doing some managerial stuff, or organizing projects, and organizing information flow, and systems, basically laying out systems for the teams to work on. So yeah, and that's the breakdown.
awesome. That's interesting. So, well, obviously, this is so. Next question. What was it like to work with Elon Musk?
Yeah, that's a that's a great experience, actually. Um, I had learned a lot, and a lot of people, have not so good experiences with Elon, and a lot of people have had really great experiences. I fall on the great experience side of things. Fortunately, he called me in for this pet project that he had, which was to get the first stage booster back and reuse it. And he was always convinced that this was the way to go ahead. When I joined SpaceX was about 2,000 people strong, and they still did not have enough people in the company focused on this objective. because the main objective at that point was to just to survive. We were doing one or two launches a year at the most, and we've had like three or four failures already in the initial. If you've read the history of SpaceX, so the company was very, very, keenly positioned on the primary mission, which was to launch the satellites that they had contracted for. What the first stage does is that it takes the second stage. It's called the booster because it boosts the second stage up to the atmosphere limit, which is at about 100 kilometers. And then the first stage usually falls back and burns up in a usual rocket launch. The second stage provides the lateral velocity for orbital velocity for the payload and inserts it into an orbit. So in his project to get the first stage back, he this was the first time anyone would have tried getting a liquid propellant based first stage booster back and reuse it. Even the entire company, even my bosses. I mean, when I was joining SpaceX, a lot of people used to tell me that they feel bad for me because I'm being set up for failure because this is something that will never be achieved. Even within SpaceX, a lot of skeptics abounded, and Elon was the one that always believed in it. So we had a very small team of 4 or 5 people. We would meet with Elon about every 2 weeks or so to discuss what our recommendations were. And what I found with him is that, and he actually practices what he preaches, meaning that he is very convinced that if you tell him that this is not going to work out, and then he'll ask you what are the chances of it working out, and we'll tell him 5%. He says, wow, that's great, that's excellent. Even if it was 1%, I would take it. So he actually practices what he preaches, which is basically if you really believe in something strongly, and even if there's a 1% chance of it happening and 99% chance of it not happening, go for it and put your entire energy into it. And at every stage, I saw him take a lot of risks, a lot of bold decisions. Spend a lot of at every stage. We're in the reusability project. We had to spend a whole lot of money, whether it was in wind tunnel testings, whether it was in developing new materials, mechanisms, which would eventually fail. A lot of them would fail, right? So, and the company was not in a huge financial standing where we had all the money we wanted. Uh, we were we were pretty scrappy in SpaceX to start with, but he just plowed on. And I think the thing I learned from him was uh, the ability to take risks, be very, very determined, and rely on your gut instinct from your fundamentals and keep pushing the team. He's relentless in that he pushes himself and he pushes the team too. So um, these are the traits that, the positive traits that I dwelled on and I dealt with. So initially we had these meetings for about 5 to 6 months. And once and then less frequently, I guess. I mean, and then in the next 1.5 years, once he started getting the stages back, he canceled the meetings with him. So I basically interacted with him directly for about 1.5 years of my initial SpaceX stint, and then he was off to different priorities, but the project had stabilized. So what I learned from him is basically people look at him as if he's a visionary and he can basically dream of things. He's not a dreamer alone. He's what you take away from his success and the reason for his success is his grit, his determination, his capability to take risks, and the deep belief in his own intuition. I think that is something that we all can learn from.
That's awesome. That must have been such a cool experience working with him.
Yeah.
So we do have a question in chat. So what are your recommendations for how to learn from failure?
Excellent question. You don't learn unless you fail. I mean, so one of the things that you have to do first is to put your ego aside. Um, as engineers and as scientists and as people in STEM field, often I see that we fall in love with our logic, with our reasoning, with our models, and with our designs, and we attach uh, our self worth to how good was our idea. Firstly, don't do that. Uh, you're just a professional. Maybe you are at the top of your game, but nature has a lot to teach, and you always deal with the unexpected when you're doing something new. So, firstly, don't attach your ego to how you came up with things, and whether they are attached, whether these ideas and trials are attached to your personal self-worth in your eyes or in your colleagues' eyes, and you should spread that across the team as well. And secondly, how do you learn from a failure? Well, firstly, I mean, no one wants to have a failure. So when a rocket blows up on a test stand, or when a Dragon capsule blows up on a test stand, it's not a fun day for anyone. I've been through that a lot, because when we were at SpaceX, we had two rocket explosions with customer satellites, and they were like very debilitating for the company. In one, we were grounded by FAA, Federal Aviation Authority, for 6 months, in the other for 8 months. And there were rumors swirling around all the time when this happened, that we are not earning any revenue. The company might go bankrupt. So these failures are expensive. Don't get me wrong, and they're not fun to deal with. But what SpaceX did from that was a masterclass in management. During that period, SpaceX built up strength. They learned from the failures, and I often now reflect back, and when I have to summarize it, I say it in this way, in the following way. SpaceX doesn't really have geniuses who do not make any errors. They have as many or more people making errors as any other company in the world. More because they're doing more, right? So when you do more stuff, and when you push the boundaries more, you make more errors. What they do have is the capability to learn from those errors and then do the next best thing that they can do after that mistake. How to pick yourself up from the ground and position yourself for success right after the failure is what you should learn from SpaceX. So the Silicon Valley also has this kind of a mantra where you want to fail fast. The reason why they say that you want to fail fast is that you're pushing the boundaries. So if you boil your choices down to two or three best case, outcomes, or best case, most promising trials, or most promising products or ideas, try them out, and when you fail from them, learn from the failure. Just take an opportunity to parse through the failure. Don't just either go around with a bruised ego and say, try to explain away the failure. Look at all the data, look at all the circumstances, try to learn as much from the failure. You learn a lot from the failures. There were instances in SpaceX where there were no known signs to what would happen. For example, the re-entry burn, where we go with the first stage and we shut off the main engines, stay separate from the second stage, and now the first stage is ballistically going and falling through space by Earth's gravity. As it comes back, it's coming back into the atmosphere at Mach 7, 7 times the speed of sound, and we have to slow it down, otherwise it will just burn up with friction. So when we do, the way we slow it down is by activating some of the engines and slowing down by retropropulsive thrust, basically applying thrust in the opposite direction of the rocket falling. And there was no known science at that time. We talked to even NASA. We had visitors from NASA. They were studying this phenomena because they wanted to implement this in Mars, but there was no science, and it's hard to create these experiments in on Earth, because you can't simulate gravity, the microgravity. You can't simulate vacuum at that scale. So there were no known science and no known experiments as to what would happen, and SpaceX could just guess what are the hazards of doing this with nozzles facing down and doing retropropulsive burn. So we knew that we would fail, but with every failure, we'd get data from the transducers, from the telemetry, and analyze the data, and then go to the next step. So it was an iterative process. It was not a. I speak of fundamentals, but this was not a science problem. This was more an engineering problem. The difference, I kind of think between them is, in science you're going for the truth and seeking the truth and knowing the truth. In engineering, you're seeking what works. and why it works and making it work. So even if we did not understand the entire science, which was NASA's approach of going to a problem, we iterated from failures, and that's how we learn. And that's why if you see the evolution of this project, you'll see that we crashed rockets, we burned rockets, and we did that for a whole bunch of time till we got it right. So the way you learn from your failure, first of all, don't have your ego attached to the failure. Expect failures if you're pushing the boundaries, and that should be not just you, it should be the entire team. That should be the culture of the company, or the team that you work in. And secondly, when you have a failure, it teaches you a lot. Fix it, and fix it for good, and then go on to your next failure and learn from that, and kind of keep evolving. Never repeat failures. So these are kind of things I learned very effectively at SpaceX.
Right. So essentially, failures are crucial because they're like your avenue of collecting data, and then you can analyze that data in order to learn more and how to create solutions towards a problem that you're trying to solve.
Yeah, yeah. And I would add that in 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 these learning curves, it's always best to have failures in test rather than in live conditions, because rockets are kind of a little separate. But you can, I mean, now that rockets are carrying astronauts, you don't want to have a failure in a manned flight, for
Right.
instance. So you want to test the death out of your product, or of your idea, of your software or your program, much before it goes into operation. You don't want to fail in service. You want to fail in test.
Right. So I do have another question. On top of knowing your fundamentals, how you've talked about in engineering and science and physics and math, what is one of the most crucial accompanying skills to have to be successful in engineering?
Yeah, that's a great question. So engineers are often portrayed these socially awkward nerds who are very good at the things that they do. They can design robots, they can design machines, they can design products, but ultimately, I think that's a caricature that we need to escape from. I think engineers are also one of the things that would make you a very successful engineer is not just knowing the technology aspect, but also knowing the people aspect of how actually work is done. When you're working on big projects, like I said before, nothing is achieved on an individual level. Uh, a whole big project can be a team of 5, 10, or 80, or even 1,000, and the way that this team comes together and achieves things is through interpersonal relationships, is through helping and asking for help. And so these are the traits that you need to develop as you go along with your career. Is don't be defensive, be transparent, be open, in fact even be friendly, and encourage help, give help. These are kind of things that and seek out mentors. And it's very important to have the right mentorship, and seek out good teams, seek out good projects, seek out good areas where you're passionate about. These are things that will make you successful. Ultimately, it's no matter how good all individuals are in a team, how they work together is what makes a big difference for the project.
Um, Unfortunately, we're almost out of time.
Okay.
But we had a question in chat, like, if you have more questions, what is the best way to reach out? So, like, what's the best way to contact you?
Contact me.
Yeah.
Oh yeah, I mean,
Okay.
my LinkedIn profile. I thought you shared that in the chat, and that's great. I mean,
Yeah, I just shared that.
yeah, I would encourage anyone who wants to reach out, be connected, to go through LinkedIn. Personally, I mean, I stay away from most of the social media, but I like LinkedIn because it gives me the kind of information I need from people I follow, and it's very professional up till now, at this point at least. And it's just a good place to feel connected, and I get all my updates from the drone industry and the drone world, and the mechatronics and all of that through LinkedIn. It's awesome. So
Right.
I think I use it quite a lot.
Cool. So we will now move on to a couple of questions that people had about DET, obviously the Davis engineering team. People were asking about how they can get more involved. So anybody in the meeting right now can go ahead and email us or contact us through the Remind or through our email, and we can meet with you about joining with the team and seeing if you're a good fit. People also had questions about what we actually do on the team. So our main three activities are to do engineering projects that help solutions in our community. We are also working on hosting more workshop Q&As like what we just did with Sanjeev, and we will be looking to get more involved into engineering competitions, both hosting and participating in them. So that's what we would be doing as a team. So go ahead and contact us if you have any questions or want to or are interested, and we can have a meeting with you.
Yeah. And also, I just want to thank everyone for coming out. And also, I want to thank you, Sanjeev, for
Yeah, thank you,
answering these
Sanjeev.
questions. And yeah.
No, thank you. It was a great pleasure, talking to you and hearing your questions. It's always energizes me and gives me inspires me to look at the next generation of STEM graduates, engineers, and scientists, and wish you all the best in your careers.
Right. Thank you. Thank you so much, Sanjeev.
Thank you.
All right. Well, we will end the meeting um,
All
right
right.
now.
All right. Thank you.
Thank
Bye,
you.
guys.
Bye.
Bye.
Thank you.